Okay, so the point of this class is to go into the basics, because I think if students understand the basics, they can go from there. You know, whether they do NFTs or mine or do whatever they want, it's up to them. So the way I look at as an educator is, if there's a technology around, you de-hype it, you try to explain things, and then, you know, I deal with adults, they do whatever they want with it. Okay, so you know, it's the one condition I have is, do not take out your wallet and buy anything in my class, because I don't want you to do that, right? No pressure. It costs zero. So everything we're doing here, it doesn't cost you any money. And MetaMask wallet, you know, don't buy anything today. What you do after today is up to you. Okay, so the main thing is, there is a few building blocks that you got to understand before you jump into NFTs and all the flashy stuff. Because if you don't understand, you know, I mean, the plumbing or the infrastructure, how are you going to understand what the jazz is on top of it? So that's why I try to explain these three topics as much as possible, even though it's kind of dry, before you get into some of the cool stuff like programming and NFTs and things like that. What that does is it at least makes people or students get some understanding the foundations, and then they go into more cool stuff. Okay, so the purpose of this session is for all of you to actually create your first smart contract and create your NFT. If you've just logged into stuff, and creating an NFT is really easy, but that doesn't mean you're going to make millions of dollars either. So this is more like an understanding of the technologies, and, you know, in education we try to do that. Okay, so I'll kind of go through very quickly. Our college is really not a big deal. It's a very nice place. It's a small community college. We have a baccalaureate degree, which I teach. We are a CAE school, which some of you know is a Center for Academic Excellence. We have our enrollment is shrinking, unfortunately. As you all know, we live in a touristy island. There's not much diversification of industries, and so on and so forth. So cybersecurity is actually on a rebound. A lot of our non-traditional students are reskilling in cybersecurity, the STEM fields. They want to get away from retail and hospitality, which is not surprising. We have a lot of things that a lot of you probably know about. We have certificates. We teach, you know, network security, security plus, the standard stuff. I just had a class on NSA Gen Cyber. We got a Gen Cyber grant, so I was teaching high school teachers last week, and so on and so forth. I'm a cyber patriot. You know, like, didn't you mention this? So yeah, so a lot of us do similar things. I've got some small ATE grants in the past that has helped me, you know, set up some of the courses and some of these tracks. Okay. One of the things that I like and I've done for a while is do cybersecurity across disciplines. What that basically means is teach cybersecurity to people who are scared of cybersecurity, don't have a math background, usually underrepresented minorities, women who don't have role models, and teaching them enough about cybersecurity so that they can just at least feel confident about the field. They don't think that, oh, it's not for me. Get past the imposter syndrome. Okay. So the grants that I've got have helped me. Now, I know this has not much to do with Bitcoins, but we'll get to that in a bit. COVID-19 was a hassle, as you all know. When you're an island, you're stuck in an island, and a lot of us were also stuck. So I had to figure out ways to do projects and stuff that was hands-on, even though we were doing things on Zoom. Now I'll do a reality check. Mark, is it working? The Zoom working fine? Okay, just to check. So Zoom is the thing that I've been doing. I even had a Zoom class with Mark in winter, right? Mark, the only issue was getting up at Hawaii time for Houston time, which was, Hawaii does not have a daylight savings time, so I'm 4 hours behind Houston or Dallas in winter and 5 in the summer. So that was a little challenging. So during Zoom, what I'm getting down is we had a lot of issues with hands-on activities, which are very important for cybersecurity education. So I used to actually meet students in the parking lot and give them things like pen testing tools, USB rubber ducky being one of them, and land turtle, and all these kind of things. So you may know them. So a lot of this NFT project started off because there was this hype of NFT, and I wanted students to actually do something that created things. So a lot of these projects were created during this pandemic timeout that we got, lock picking and things like that. Okay, I'm sure all of you were challenged by it, and we are kind of like a little out of it. Okay, so let's start with Bitcoin. And what I do with students is I kind of interrupt the slide just because people get bored of slides, you know. So what I'm going to do is I want all of you to type in your thing BTC, okay? And you know, you can make notes because this is what you want students to do. Type in BTC and tell me what's the price today.
It's down.
Okay, right. Now go into that screen, and I'm being recorded, Mark. That's why, otherwise I kind of move screens. What happens, I think, is if I move too many screens, the recording might miss some of the thing. Or are you recording my desktop? Okay, so go into a 1 year timeline and tell me how much the price has gone down. If you just, yeah, it's probably lost a lot more than the S&P 500 has. Okay, and so the BTC is the tick symbol for Bitcoin, and one of the things you want students to do is just type in BTC and check it out. Okay. All right. So the other thing to understand is to explain to students is fiat currency versus, so it helps to have some dollar bills in your thing. So who's on the back of the $20 bill? Can't see.
Should we buy the stock?
Huh?
Should we buy the stock?
I have no comments on buying anything. I do not tell anybody to buy or sell or whatever. Okay, so fiat currency, you know, so I have every student take this out. A lot of students actually don't know what a bill is, and the bottom line is this is a denomination of 20, marked by the U.S. government. It has a number, right? So it's supposedly traceable if you can follow this number. It's from the U.S. government, and it can be used anywhere in the world. Now, what I try to explain is for $20, the denomination, you get what we call a basket of goods, right? You know, in economics. So with inflation, you get less in your basket right now than 6 months ago. So this is called fiat currency. The thing about fiat currency is it's issued by somebody, and it's tracked by a bank, because if I put, you know, I'm not supposed to have a lot of money that I supposedly didn't earn, right? So all the currency that I have is supposedly from my income, and so there's a tracking. Okay, so you can get into this as much as you want, but most of you know what fiat currencies are, but it sets the stage for cryptocurrency, which is a little different. Okay, this is my slide, and the reason I like the slide is because these are all the dates where I made presentations from 2017. I'm kind of very, yes, I've done a lot of presentations, and I've updated the slide every time, or I always do it a few days before I do the show. So this was done on Saturday, for example. So you'll be amazed at the difference in prices, okay? But to answer your question, this is a good profit, because in 2007, when I thought, well, not 17, let's just say at this price, 17, you know, even with the crash, it's 4 or 5 times that it was a few years ago. So Bitcoin investment, if you think about it, you know, is an investment if you're willing to stick it out for a long run. Now, of course, it went up very high last year in the fall and has dropped tremendously. Okay, and there was a huge spike in December 2017, spike up. So if you follow the trends, if you just think of this as a chart, it's gone up and down, and you know, so very volatile. But let me start off with, let's go to a little bit on history, which is very important. A Bitcoin paper And again, if you want to get into a class, you can actually show the paper by Satoshi Nakamoto, who's a pseudonym. You don't know who the person or persons is. Was published in October 2008. The first Bitcoin transaction was in January 2009. So Bitcoin has been around as a cryptocurrency since 2009, for a long time, 14 years or so. Okay. One of the great things about Bitcoin, or the Bitcoin system, was the blockchain that was created with it. Okay. And that exists to this day. A few things about Bitcoins. Right now, and again, I update the slide all the time, we have 19.1 million Bitcoins in circulation, okay, as of a few days ago. But the total number of Bitcoins that can be generated by the system that was created by Satoshi cannot exceed 21 million, and that's to prevent inflation. Okay, so fewer and fewer Bitcoins are generated, okay? A few things about Bitcoin. Bitcoins are generated in what is called blocks. Okay, and we'll get into blocks in a little bit. They create about every 10 minutes. And what happens when you create a block is somebody has to verify that the block is legit. Okay, and it's called mining. And we'll get into a little bit on mining, but let me just explain this mining a little bit. Think of when you packed when you pack in your boxes. You're moving in an apartment, right? You put all your stuff into packing boxes, right? And whoever the transporter is taking your stuff, what do? They itemize everything in which box. They have a kind of a list, or they're supposed to, and they give you the list and you sign off on it, right? What does that effectively mean? It effectively means all those packing boxes and its contents have been kind of certified at a certain point in time, your departure. And then when you get it back somewhere else, you're supposed to verify that you got everything back, right? A block is something similar. What happens is all the transactions are in it. Transaction could be I gave Ann half a Bitcoin, Ann gave you half a Bitcoin. All these are all transactions. Think of a block as a collection of transactions. Okay, it's like your packing boxes. Once it's been verified, it's shipped, it goes off, right? And that's what a block is. And in Bitcoins and blockchains, these blocks have been created since January 2009. The first block, known as the Genesis block, was created in January 12th or something, 2009. Now, here's a little exercise. Which block exists now? What is the block number now? Okay? And to do that, what you want to do, and I have to break this presentation because otherwise it gets a little boring. You go to the browser, and what I want everybody to do is go to blockchain.explorer. Okay, which is this site. blockchain.com/explorer. Okay, it's a very busy site. So what I want you to do is I want you to go here, go to blockchain.com Explorer and click Bitcoin. There's lots of stuff here. Click Bitcoin, and then it doesn't refresh for some reason. I went up to the top and I clicked it, and you should get the screen. So let me know if you have the screen or not. Everybody has the screen? Okay. What I want you to do is tell me the block number. What is the block number now? 746649, right? Okay, so if any of you are really into blockchains, write that down, because at the end of this discussion, it'll be a different number. Every 10 or so minutes, a block is generated. Okay, it's like a heartbeat. And it's been going on since January 2009. This is the number of blocks that have been actually created in the Bitcoin system since January 2009. It's called the height of the block. Think of it as a height of blocks, okay? And 746649 is the latest height. Okay, now what is in a block? And again, the thing is to be interactive with students, to just give them a feel for it, So click height. And again, just make sure nobody gets lost in this. There's a lot of details, and you don't have to understand everything. a block has a bunch of transactions. So just go scroll down and you'll see all the transactions. Okay. Now very simply, a transaction is from one person to another person or persons. And this is like a code. So this could be Anne's code, let's just say, and she gives it to two of you guys also code. These are just codes. And so the transaction itself is public. Okay, so like I just pick any transaction. I don't know who this person is. This is an address. It goes from one address to two addresses, and this was 0.000432 bitcoins. Okay, so the transaction itself is public, but from whom it came from and to whom it went to is anonymous because it's a code. So it's a hash code. Okay, so that's at a very fundamental level. A block is a validated set of transactions. Okay. All right. So that's the history of Bitcoin, and we can get into more details, but we don't have time. So students need to understand a few fundamental things. One is that there is going to be a limit to the number of Bitcoins that are going to be mined. Right now we are at a certain level, and that if you mine something, you get a reward. That's how Bitcoins increase, because you get the reward for mining something. We'll get into mining in a little bit. So this is one way to explain graphically how Bitcoin works. When we write a check, we have a sender and a recipient, right? Take the closed captioning off. So Bitcoin is essentially a code, a public key to a public key. Okay, from a public key to a public key. And by the way, when I asked you to create a MetaMask ID, you created a public key. It's right there on the top of your MetaMask screen. So a public key is your public identifier of who you are, your account basically. But your transaction is signed, digitally signed. Most of you who are into computer science and cryptography, you probably get this. So SHA-256 is the algorithm used. Satoshi used in 2008. Just remember, he was doing all this, he created this stuff in 2008, right? So SHA-256 was used as the digital signatures. So the signature validates the fact that this public key is legit, that this was indeed the person who sent some Bitcoins to this person. Okay, that's why it's a signed transaction. Now, everything about the transaction is public, like the amount and the date and all this timestamp is all public. So everybody knows in the Bitcoin system the money that's going from one place to another place, but you don't know who is sending it to whom. Yeah, so that's one of the things about the Bitcoin system. This is a little bit of detail. Let me just explain this simply. Let's just say all of us downloaded the entire Bitcoin system. Okay, I not recommend that, but let's just say we did. We'd be what is called a full node. We've copied the entire Bitcoin transactions from the Genesis block to today's block. 11 years of transactions into our system. Okay, it's not a good idea to do, but let's just say you do it. You become a node. And in a P2P network, what happens is every node has a copy of the latest transactions, latest state of the system. Okay, so all the nodes, what they're doing is you have the option of what is called mining. Very simply, mining is verification that transactions are legit. So let's just say I gave you 0.5 Bitcoin. That would be from my wallet to your wallet, right? It's a legit transaction. But what if I try to give that same Bitcoin to you? That'd be double spending, okay? Which is hard to do in paper currency because how are you gonna make a copy of a bill? But in digital currencies, you can, right? I mean, if I had half a Bitcoin, and if I try to double spend it, then I could try to make two transactions with half a Bitcoin. But all I had was half a Bitcoin in my wallet, right? So the mining makes sure that there's no double transactions and all the transactions are legit. That's what mining effectively is. Mining is a verification system. So all the people who are full nodes are capable of mining. That's why mining takes a lot of energy, etc., etc. Okay. Mining is a somewhat complicated topic, but but if you want to explain mining, think of it as a verification process, making sure that if I only have half a Bitcoin, I can only spend half a Bitcoin. Okay. In the cryptocurrency world, whatever you have in your wallet is considered unspent. In other words, if I have 1 Bitcoin, at most I can spend 1 Bitcoin. Okay, so the validation check means that if I have any transactions, let's say I have 1 Bitcoin in my wallet, I cannot have the sum of my transactions past this point cannot be more than 1 Bitcoin, right? Because otherwise I'm overspending what I had, right? That's the essence of verification. This whole system would fall apart if we could spend more than what we had in a wallet, right? So the Bitcoin system has survived 12 years because of verification. Okay, so that's what mining is, and we'll get into a little bit of proof of work in a little bit. There are lots of challenges with Bitcoin. How do you, or at least used to be, right? As there are with many other things. Who do you know who you're paying it to? Like if I send it to a wrong code, it's gone. There's no reversible transactions. You can't reverse a transaction. I can only, if I give something to Anne by mistake, the only way I can get my money back is by begging and pleading to Anne to return it back to me, which she might not. So there's a few challenges about the Bitcoin system being crypto, all crypto and no control. There is no trust on any third party. Okay. The US dollar is what? Guaranteed by the US government as a legitimate tender, right?
Sort of.
Well, I mean, it's used all over the world. There's more US currencies outside the US than in the US.
I'm just cynical.
Right. But there is no no central bank or clearinghouse for the cryptocurrency. It's just a system that's been running since January 2009. And people value it in different amounts, but it's kind of running. It's a peer-to-peer system that has been running for 13 years. It's just amazing in itself. Okay, but this is the challenges slide. The biggest thing that I want you to point out is double spending. Okay, because if this happened, the system would just collapse overnight because there'd be no value to it. If I had X number of Bitcoins and I could spend Y, which is greater than X, then this is just monopoly money. Okay. Inflation on Bitcoin is resisted or tampered down because of the fact that you really cannot create more than a certain amount of Bitcoins. Okay. So before we go to blockchain, just a few demos. What I want you to do is I want you to go back to Blockchain Explorer and tell me what the latest Bitcoin height is. These are just exercises to keep students in motion or in sync. Did we get a new block?
Not yet.
Not yet. Okay. Because it's taking a little bit of time now, and in fact there was 43 minutes, which was a long time. You see these things called miners, ant pool, right there. These are usually large conglomerate mining pools, and they usually now control mining in Bitcoins. These are large groups of miners across the world. So if you click on ant pool, you'll see all the things they mined and they won. Okay. But don't go too far in this blockchain because it kind of there's a lot of detail and might get a little confusing. You want to make sure your student understand the basics and not any more. So fiat currency, Bitcoins, its history, a cryptocurrency, going from a wallet from a public address to another public address, but the transaction itself is plain text. Okay. So that's the essence of Bitcoin. Okay, Bitcoin works on something called blockchain, and this is probably the only joke that I have in my presentation.
We lost it.
I know you like jokes,
Okay.
but it solves all our problems. Make coffee tomorrow. Blockchain is going to solve the world. there's a lot of hype to blockchain and NFTs. I completely get it. But I think if you're in the computer field, you will be kind of impressed by the fact that the system, peer-to-peer system, has been working for a long time. Some of us probably know Napster, and we know a few other peer-to-peer systems, BitTorrent, and also peer-to-peer systems are not new to a lot of us. But the fact that this crypto thing has been running on a peer-to-peer system for so long is actually pretty good. And what it's running on is the blockchain. Okay, and I'll get into a little bit, but what I was thinking was maybe for students who are new, it's probably better to do a demo. Sometimes it's better to do a demo before you get into the weeds or not. Okay, so the coolest demo that's been there, I did not put it on my slide, I'm sorry. But if you just Google blockchain demo, you should see this guy called Anders Brownworth. Okay, if you just Google blockchain demo, you'll find it. And if you don't, it's on this thing. It's a little hard to, you may or may not, but the point is eventually you'll find it. And let me just explain this to you, what a blockchain is. All right, because you guys will find it eventually. So a blockchain, if you look for blockchain demo, you'll find this site. But it's more important to understand how to show it to students. Okay, so blockchain is a list of transactions. Sometimes I use the analogy of a bucket and water. Sometimes I use the analogy of a file folder with little files in it. Whatever works for you. So block 1 has a nonce or a number, and just put any transactions like 1, 2, 3, 2, 3, 4. Doesn't matter. Doesn't matter. I have 3 transactions, 4, 5, 6. Okay. The point is, you hash this entire block, which means you create a code that defines this entire block and its transactions. So you click mine. Okay. This is a very important concept. So it creates a hash code right here of all the transactions in a block, and there's usually few hundred transactions in a legit block. Okay. Then what happens is, it's chained to the next block that is forming, because this hash goes right there to the previous block. Okay, and that's how this block gets chained to this. That's the notion of blockchain. So let me start creating another thing. 5, 6, 6, 7, whatever. You know, these are transactions that are happening in the world. Okay, so if I verify something and I mine it and say, yes, it's all legit, it's all ready to go, in about 10 or 15 minutes, I click mine. This is obviously a very simple demo, but the point you're trying to make is this hash, which is this whole block's hash of including all the transactions, is linked to the next block with the previous hash. And this hash hashes everything, including this hash. Okay, so hence the chain. Okay, now a simple demo would show that you go here and you change, oh, I'm trying to mess with it. I'm trying to I made Ann a transaction, but I want to delete it. You know, I want to repudiate it. I'm going to say, no, Ann, I didn't pay you anything. So I'm going to take the transaction out. What will happen is this block, this hash is no longer valid because you've changed this thing, right? So it's only valid if every single transaction is there. So what this is trying to say is that as the blocks are formed over time, the older blocks are hard to change and mess around with. In other words, this is a ledger. You can't change the ledger. This is a fundamental concept in blockchains, is that it's immutable. You cannot change what has happened. And typically, if the blocks are 6 blocks old, or 60 minutes old, it's nearly impossible to change anything, because as you can think, the blocks are increasing, right? And the hash of previous blocks is in the hash of this block is in this block. So if you were to change anything in past blocks, you'd have to rehash them and create new chains. Okay, it's basically very hard to do. Okay, and so this demo kind of gives you an idea of the integrity of the transactions. And this is an old demo; it's been around for many years. So I'd recommend just showing this demo to get a basic feel for what a blockchain is. Then you can get into some details about stuff like this. I'll keep on going. And blockchains are very important. Those of you in computer science will probably understand this. This is some folks call it like a linked list, but it's really not. The way I look at it is these are blocks with transactions. The hash of every block is in the next block. Okay. Sometimes you get what is called orphan blocks, like blocks that have transactions in it but are really not finalized, and they're just hanging around in someone's computer. That's really what it is. But there's always one chain that is called the longest chain. Okay, so let's just say you downloaded went to bitcoin.org and downloaded the Bitcoin system. You would get the longest chain. You wouldn't get some of these orphans. These orphans are not finalized buckets. Okay, so the chain, the Bitcoin chain, is essentially created on the longest chain. So let's just say we are all miners and we are trying to like work on the latest pool of transactions. If we finalized a block, we would not tack it around here or here. We would tack meaning we would link it up with the longest chain. Do you understand? So that's what creates the height. Remember the first thing I asked you to do, what's the height of the Bitcoin? The height of the Bitcoin is an extension of the longest chain. So think of it that way. So this chain is kind of perpetuating in time. Okay. But there are many orphans that are there in many systems, and eventually the Bitcoin system just kills these things so that you don't have these things anymore. The transactions that are in these blocks go to the next block after that, because there are transactions in these blocks, right? Could be legitimate. Okay? So that's how the blockchain works. It's a decentralized peer-to-peer network that are running on people's computers. Now, typically it's running on miners who are like Antpool, which are large conglomerate miners. They're usually not running on my machine. A little bit of technology here. If this is a computer science class, people can understand this. It's a distributed database that is synced up every 15 minutes or so. It's a peer-to-peer transmission. There is no central server per se. Every node has a copy of every transaction. There's transparency with pseudo-anonymity. What does this mean? This basically means that public keys are sending transactions to another public key. I have a wallet, I have a public key. You have a wallet, you have a public key. I send something from my wallet to your wallet. Okay, that's pseudo-anonymous because we don't know who, the system doesn't know who owns the wallet. Okay, but how much I send you, the money, how many bitcoins I send you is public. So it's transparent. There's transparency, but it's pseudo-anonymous. You don't really know who the public key is. The main thing that you want to explain is number 4, irreversibility of records. Okay, so I'll have you read this, but the long and short of it is, once a transaction is in a blockchain, that's it. Okay, you can't reverse it, you can't fix it, you can't fudge it, you can't do anything. It's done. In case you're wondering, how can you if you made a mistake, how can you get your money back? Well, that's another transaction. I mean, you have to make another transaction that reverse, but you cannot change any original transaction. Okay, that's a fundamental concept in blockchain. If students have a basic understanding of cryptography and things like that, they'll understand this. I don't have to explain. You probably have courses where you teach hashing and things like that. What is a hash? Basically, a hash is a fixed number of code, usually a hex code that kind of describes any content. Okay, and there are many hashing examples and signatures and things like that. But let me explain this slide a little bit because it's kind of important. When you created MetaMask, right? You got those 12 words, right? You had your password and all that. That's essentially your private key, right? It's you have recovery words, you have passwords. That's in essence what's known to you. Okay. But what that does is it creates a public key that is known to the whole world from your wallet. And if you go play around in MetaMask, you'll see the public key right on top. And as we all know, there is a private public key combination. So when I send a Bitcoin, remember the check that I showed you? When I send a Bitcoin, I sign the transaction with my private key, and the message is basically a transaction. So I sign the transaction with my private key, and that transaction is out in the blockchain, right? As we saw the blockchain transactions. The only way the other person knows that it was from me was if they verify the signature with a public key. So I sign it with my private key, but it can only be verified with my public key, which is available to the whole world. So what the public key does is goes with the signature and says, yes, this was indeed from Ann, or this was indeed from me to Ann. And then there's a certain level of comfort. Okay, so this is the essence of the Bitcoin system, to make sure that you know who you sent it from, and that person you sent it from was legit. Okay, so I try to explain this thing, but sometimes students get it, sometimes they don't. Let me stop over here. How am I going? Fast? Too fast? Most of you understand this? This is basic crypto. Now again, sometimes students have no prerequisites, right? Then you have to explain a little bit about hashing and SHA-256. You guys teach all that stuff. This is easy. This is very basic. What is not basic is this slide. Okay, so Satoshi Nakamoto, or whoever that person is, wanted the system to perpetuate. The only way it could perpetuate is if people worked and did some effort to validate the transactions in the blocks. Nobody would make any effort if there wasn't money involved here, right? Human nature. So what happened, the system was built in such a way that we would solve essentially a puzzle. Okay, the best way I can explain it. It's called proof of work. Proof that you did work. Not only that you did work, that you actually solved the problem. So what exactly is it? What it is that, remember you had all these transactions in a block. So let's just say we have a block in 100 transactions. Okay, the puzzle is the system sets you a certain, what is called a target, which is a long number. Let's just think of it as a long number. And what you're trying to do is you're trying to figure a magic number, which is like this red column, so that the function of all the transactions and that magic number that you're trying to figure out, the hash of all of this leads to a certain number that is less than the target number generated by the Bitcoin system. Okay, so the Bitcoin system generates the target. Imagine it sets up this target right here, and you're trying to make sure that you're just below this target, not above it. Okay, and so this is called mining, where people are actually trying to guess this number so that it's actually less than the target. Okay, and this is done by machines, which are cranking out these numbers, instantly. Which is why mining takes all this electricity and the power and all these kind of things. Which is why nowadays mining are done by these big time conglomerates working across the world in very cheap places with cheap electricity, including Texas. Since China cracked down on mining in China, a lot of the mining has actually come to the US and places like Iceland, where it's very cheap because it's cold, and the electricity is cheaper. But what in essence mining is finding what is called a hash number, and that's why they call it a hash rate, where this number called nonce, the hash of the function with the nonce leads to a hash number that is less than the target. Okay, I try to explain this by saying that somebody sets you up somebody gives you a puzzle, and you have to find all the blocks to the puzzle, and it's very hard to find that last block, and you're keeping on finding it. Your computer is trying to do its best to find it. That's called mining. Why do everybody do it? Because you get bitcoins as a result of it. Okay, how much do you get now? 6.25. When Satoshi started, it went to 50. Every 4 years, he decreased the reward intentionally. So 50, 25, 12.5, 6.6, and then it'll go to 3.25, and it'll end at about 100 years. Okay, so this is the reward from mining, and that's why people mine now, and it's large conglomerates.
Wait,
Yes,
did you call
question.
the amount that they get?
6.25 bitcoins if you solve a block. So remember we were going,
Wow.
so 6.20,000 is quite a bit actually. It was not much so, so 6.25 blocks. So if you go to Blockchain Explorer, you see all these miners who won, Antpool and all these names, they get 6.25 bitcoins now, and it'll decrease every 4 years. It's supposed to be half of the amount. So it started at 50, 25, 12.5, 6.25, 3 point some. Okay.
So someone who says they're operating data mining like one of our build members, they're not getting paid until they solve a block.
Yes,
Wow.
exactly. And so it's not. I mean, it's not something that you would do for fun. I mean, this might have been. Nobody did this 10 years ago when it was probably lucrative, but the price was low. And so with the price of Bitcoin crashing, it becomes even less lucrative to do it. But if it's 40,000, 6 times 40 is a lot more than. But my simple message is it's done by large corporations, by large groups of people, not by solo individuals. Just doesn't make any sense.
So what pays that out? Where do they get the 6.25 Bitcoin to pay out?
Very good. So it goes to their wallet.
I know, but what's it come from?
It comes from the system.
Okay. I
The
know you're not
Bitcoin-
creating any more new Bitcoin.
You have a limit to how many bitcoins you can create, but the Bitcoin system, that's a good question. The Bitcoin system generates new bitcoins when a block is mined. Okay, but it intentionally, Satoshi decreased that reward amount by half every 4 years to kind of like to make a limit on how many bitcoins could be generated. That's how the number of bitcoins in circulation increases, right? But it's capped at 21 million. Okay, so now in case you're wondering, how do people make money on Bitcoin? They make money on transaction fees. All right, so on Coinbase, like you own Coinbase, what is the percent? 4-6%? Quite a lot. It's more than the ATM fees. So every time so transaction fees is every time you transact something they make. So they don't make money on mining, but people are making money on transaction fees. Okay, so transaction fees are going up in time. Okay, so how am I doing for time? You guys tell me, because I've done this for 4 days. I've done this in 20 minutes.
We have 15 minutes.
Okay.
2 minutes.
Okay, so Bitcoin till about, nobody cared for this stuff, including me, till about 2015. Okay, it was running and nobody could care less. It's true. So in 2013, 14, 15, a guy called Vitalik Buterin and Gavin Wood and a few other people said, this is boring, just a cryptocurrency running on blockchain. And so what they created was Ethereum. Okay, this is a whole topic on its own. But the key thing that I want to tell is Ethereum allowed you to create essentially a program that could run on blockchain. Okay, this changed everything. Programming, like C code, and what can the program do? Basic stuff, functions, store data, store JPEG files, and very humble concepts, but it was like a programmable blockchain. Okay, so Ethereum also had its coin, which was Ether, ETH, like BTC, ETH. But the radical different concept was they allowed you to create what is called tokens. Okay, token is, think of a token as a digital unit. I call ABC token, HITEC token, whatever. Tokens were digital units that could be traded by anybody in Ether. Ether was the currency, right? Token was what you created. So, you could do a lab where you create a token. It takes a few hours to do, but that token has no value, but you can trade, you can assign it any value you want. So that led to a lot of tokens which exist nowadays. Okay, and the fact that it's a program with little images in it led to NFTs. And the first time I heard of a concept called Hello Kitty, I thought it was a joke, but it's not. So just for fun, go to the Hello Kitty's website. Okay, Hello Kitty's is the kind of thing that we all should have loved when we first heard of it. But sometimes you just don't take things seriously. So Hello Kitty's was the first, basically, NFTs that was created. Okay, and it's come a long way since then. Still around. Where is Hello Kitty? Hello Kitty, I think, not kitties. So you just have students play around with it. It's Sandro, I think. Now this is not the Hello Kitty site. This is. It is? They own it now? Okay. So Hello Kitty was the first, site. Then there's been many others. Okay. But these NFTs were created. Actually, why am I saying Hello Kitty? Actually, it's CryptoKitties. Sorry. Whole different. This just shows how much I'm not into this thing. CryptoKitties.co. Okay. CryptoKitties. So CryptoKitties started actually 4 or 5 years ago, and what is it? It's a JPEG. It's at the very basic. It's a JPEG file of a little kitty, and you can mate, you can have children, you can do all sorts of cute stuff with it. They can have clothes, everything and everything. Okay, so this is fun for our students. But the main thing is just look at how many wallets and how many CryptoKitties there are. Just look at some stats and look at some kitties, okay? But the joke is, well, not joke. The fact is this has been around for years, okay? And then there are a few other sites like this. CryptoPunks, I think, was the other one. You should at least bring up these two sites because these were the original. These were the original sites that CryptoPunks, right? Okay.
But there's no underlying support of any kind?
No, I'll explain. I'll explain to you what it is. So when CryptoKitties started, it was a lot of hype and things like that. But I don't want you to get too deep into this because there's, first you need to understand what Ethereum is and what smart contracts are. But as a segue, you can just bring up CryptoKitties. I mean, because it has been around for a while, and it was one of the first images as a smart contract. Okay. Okay, so let's get back to where we were. So Ethereum started in 2015. It kind of changed the way people looked at blockchains, specifically blockchains. And there was quite a lot of development and work that happened since then. Okay. I'm not going to go into all this stuff. There's a few differences. The main difference is has a general purpose programming language. You can program the blockchain. You can add code does stuff, and then that led to things like off-chain. So if the blockchain is so tiny, how are you going to refer to documents? Okay, how are you going to have a long video file? Well, obviously you can't put it in the blockchain, so you have it off the chain. So when you program the blockchain, you can say, okay, this is the link to something in some other system. So it led to a lot of things that a lot of us know in distributed databases. Okay, and it led to a lot of programming effort. Okay, and it led to languages like Solidity, and now I'm learning Rust, which is used for smart contracts. So it changed the dynamics of Bitcoin and blockchain, which is just a cryptocurrency on blockchain. Ethereum lets you create programs on blockchain. Okay, so this is what it is. It's a state machine, which has a state. These are all the transactions in the state. All of you who are Ethereum nodes will have the same state, but it's still a P2P network, and it believes in consensus. I just put up the slide just so that everybody knows you deal with really small numbers. Okay, this thing called we. These are famous people from computer science that you probably can know. Nick Szabo was one of the first people, and Hal Finney. But these names are familiar, and basically ether is the unit, 10 to the power 18 we, and these are all breakdowns of it. Okay, I just put the slide up for fun. It was created in 2015, and most of the time you're dealing with 2 units, ether and we, but really small numbers. Okay. The most important thing, and we went into this a little bit, is blockchain transactions is a public ledger. Everybody can see it. Okay. You can have it offline if you actually store it offline. And there is indeed privacy issues. There is this notion of whales. A whale is, in the financial world, is somebody who has a lot of money. And whales are often tracked because they're moving lots of money between one wallet to another wallet. Okay. I'll go very briefly into what a DApp is, distributed app. Okay, because this is like a whole topic on its own. A distributed app is a website that uses the blockchain as the P2P infrastructure and the database, and it uses programs to deal with the website and the DApp and a smart contract. So the smart contract deals with the website, and the P2P engine is running it. Okay, so when we create websites, what we do is we have a client-based code, we have server-side programming, and you're doing HTTP and all that. So we know traditional web development. So just think a little differently. So there's your client-based code. You have a P2P system running on the blockchain, and you have your code running on the blockchain. Okay, your smart contracts running on the blockchain, and then what you have is off-chain databases. So website, blockchain, smart contracts, and off-chain content like videos and things like that. So this is known as Web 3, and it's going to solve all the problems, and it's called distributed apps. Okay, now distributed apps is not the scope in this class, but it's something that you should at least know. And if you go to blockchain.com, you'll find tons of distributed apps. There are lots of them. But I just put one slide on it just for the sake of time, and you'll see words like Web 3. What is Web 3? Web 3 is essentially not using a web server, but using the blockchain as kind of like the P2P machine engine that does the coding. Okay. All right, so let's get into smart contracts. Smart contracts is a program that runs on a blockchain. It's just as simple as that. Okay, and it resides on a specific address on the blockchain, and we'll do a simple code that kind of explains this thing. So there are 2 types of contracts on a blockchain. One is your wallet. Your wallet is essentially called an external owned account. Okay, and then there is another account that is in the machine itself. So when you created your wallet, you actually created an external owned account, external to the blockchain. Okay. So this is just a long description of what a smart contract is. This is the simpler explanation. It's a program that runs on the blockchain, on the Ethereum or simple blockchain. Okay. I'm not going to get too much into Solidity. It's one of if you are C programmers or programmers, you'll probably get this. It's not that hard. The only thing I want you to know, it's not backward compatible. You have to actually pick a version number of the program, and if you pick later version numbers, your code might break if you're using an earlier version. If you program to a later version and you use an earlier version, it may not work because it's not backwards compatible. So Solidity is one of the code. Rust is also becoming more popular in writing smart contracts. You don't have to write it in Solidity. There's a compiler that creates binary code, right? And then in the blockchain, you have this binary interface. And I'm just kind of skimming through this. Okay. If you're into programming, if you teach programming, if this is part of a programming class, then yes, by all means, you can delve into some details in Solidity. Students generally get Solidity if they've known JavaScript, if they know C, if they know any object-oriented programming language. Solidity is not that hard. But what you want to explain is gas. Gas is the simplest way to explain it is tolls. Okay. If you're on a highway, you pay tolls. Why? Because it was created with public funds, right? Highways are generally created with bonds or something like that, and you're paying this back to the government or the local government. That was the whole concept of tolls. And in the same way, Ethereum runs because of this thing called gas. You pay gas for anything. It's like a fee. If I put a smart contract on the blockchain, I pay a little bit of gas. If you use my smart contract, you may pay gas. Gas fees change over time. Sometimes they're high, sometimes they're low. And actually there are websites where you can see what your latest fee is. So the transaction that I'm doing to sell something, let's say I give you half a Bitcoin or something, the cost would be half a Bitcoin plus gas fee. Okay, gas is just think of when you drive from place to place, it's not just the price of your fuel, right? It's also the tolls. So think of the amount of transaction doing plus gas is just the price of using Ethereum. Okay, that's what it is. You know what? I didn't have this, but let's take a break. Let's segue and you tell me what gas prices are now. There are websites for this. Ethereum. I would look for Ethereum gas prices. Something like that. You tell me. And this is actually a very valid exercise that you can show to people about the changes in the gas price. So what is it? Ethereum gas price chart. There you go. Correct. So there's an average, there is low, and there's high. Okay. Now, very simply, what this means is that if you want your transaction to be implemented, you pay the high fee. If you don't care about whether it's implemented quickly or it's put in a block, you can pay the low fee. But then there's an average fee. So this is the average gas prices, which, as you can see, changes over time. And some days it peaks very high, peaks very low, etc. So that's gas. Yes. I'm
looking here. I just Googled Ethereum gas prices.
Yes.
I've got something called OpenSea sale, Uniswap, V3 swap. What are those?
So OpenSea is what we're going to do. OpenSea, okay. These are marketplaces that lets you transact, and these are the gas prices they charge. Think of them as Exxon or whatever gas station you go to.
Okay.
Yeah. It's something that people don't think about, but when you teach this thing, you got to understand that Ethereum system isn't just running on its own. The gas is being collected as part of every transaction. Okay. So the gas price is an important consideration. Gas is paid by the user who initiated the transaction. Users are discouraged. So why do you have gas at all? Just to stop you from messing around with the system. You know, like if you can program it, you could spam the system too with garbage code and this and that. But there's a cost to you to do that. So the last point over here is very important. Okay, so please read this point. Users are discouraged from calling functions and just messing with the system and doing things that you really don't have to do. Okay, so that's the reason for gas prices. Let me just take this. Okay, where is my mouse? There you go. Okay, So finally we come to the topic of NFT. Okay, so how many of you collected cards, baseball cards, or
Sure.
any of them signed by somebody famous? Okay, it becomes even more non-fungible. Basically something that can't be exchanged for something else. Okay. You can exchange this glasses with something close to it. You know, this is from Amazon. You can exchange by a $20 bill with another $20 bill. Hopefully it's legit. It's the same thing. Non-fungible means it's unique, cannot be exchanged. So the simplest way I gotta explain it is baseball card, any collectible, anything that is unique in its existence. It exists by itself. Okay, like a numbered thing, like a painting with a number or stuff like that. Okay, and so how is it created? By a smart contract. Okay, and what is CryptoKitty or CryptoPunk? It's really just a JPEG file, but taken in the context of blockchain, as I explained it, I think you can understand how it can be unique, right? It's unique in a block. It's sitting in a block that was created years ago by somebody. You know, you can't change the block, so it's unique in that sense. Okay. So you can read some of these things, but what I'd like you to do is try to read the left column, because we all know what the right column is. They are digitally unique. Okay, so it's like your baseball card with somebody's signature on it. It's not. There's nothing else like it. Each NFT must have an owner, the owner who created the NFT. But more importantly, you also know who owns it now. So I can sell my NFT to somebody else, but I'm still the original owner. There's a current owner. And all those ownerships are part of smart contracts in a blockchain, so they can't be changed. So that history of ownership is fixed. Okay? NFTs are just like anything else. They are like a token. They can be traded for whatever value. And by the way, NFTs in general have crashed in value just as Ethereum has in the last 6 months. That's another subject. OpenSea is a marketplace. OpenSea is just a marketplace. Okay. Content creators can sell their work anywhere. Yes, I can create a JPEG. I can create an NFT and I can sell it in any, and that's no different than selling this glass on Amazon versus xyz.com or whatever marketplace. I mean, it doesn't matter. Creators can retain ownership. This is a big deal. Okay, if I created that NFT, I own it, and I resell it to somebody, I still have the original ownership, so I can get royalties if you do something with it. Okay. So these are some things about NFTs that make it a little more interesting. Doesn't mean it should be hyped up and solve all you know. The reason I have OpenSea is it's really made it easy to do all this in a classroom and for students. This is just the bunch. This is just the top thing. I just put this for fun. You'll see Bored Ape Yacht Club right there, which is the most hyped up thing in the world.
And Tom Brady.
Right, but look at the loss. Look at the red. Look at the percentages here. Yeah. Okay. So to actually do NFTs is pretty easy. You set up your wallet, which is the MetaMask thing that I've been talking about. You create your collection. Think of an artist, right? They have collections. They collect, like somebody who creates jewelry, certain collection, jewelry for this or that. And then you upload your NFTs. And so here's a short version. 10,000 NFTs, 50 to 100 categories. Okay, that's the norm for any company who wants to hit the big time. You need about 10,000 different images, and that's what the Bored Ape Club is. And you want about 50 to 100 categories of images. Then you're in business, supposedly. So you need a lot of NFTs. Okay, so what's a wallet? Wallet is actually a pretty complicated thing. But a wallet, think of a wallet is at least a software wallet. There are hardware wallets too. The software wallet it tracks your cryptocurrencies by being connected to a blockchain. So MetaMask is a company that connects to the blockchain and gives you a piece of software that you download, and it has all the coins and whatever you want. It authenticates you on the internet. So anything you do with the blockchain requires a wallet because MetaMask is authenticating you. That's why you need MetaMask or a wallet with OpenSea. Okay. But MetaMask by itself is different. There are like 25 wallets. So I usually use MetaMask as an example because it's just very common. But there are many other wallets. Okay. I did this just for fun. I created my own OpenSea account and did all these pictures. Anybody can do it. So what I like to do in the little time we have left is just a few things, just for fun. Okay, so and it's all over there. The first thing I want you to do is, especially those of you who teach programming, is go to Remix. Okay. And if you have a computer, I'll show you how to do it. It's kind of important to do this with students. It's remix.ethereum.org. Remix, R-E-M-I-X, Ethereum, E-T-H-E, Ethereum.org. Okay, you'll get a site like this. This is an online IDE, online development environment. It's a little clunky. I don't like it too much, but it is what it is. So you click on Solidity first, just to make sure you're on Solidity. And if you can't do it, I have all these slides in my presentation. You go to the top left, and you get this. I'll do this twice, like I do in the classes. And then you click on Contracts. Yeah, everybody there? Okay, so we're going to create a simple contract for Hello World, but those of you who are in computer science, you'll understand this. It's not really a big deal, but there's a few nuances that you need to know. You're creating a contract. A contract is essentially a program with a .sol extension, which is .solidity extension. So you're creating a contract. So in this contract thing, if you right-click, you'll get New File, and in New File, just type anything. Hello world. Okay, doesn't matter. And then if you hit return, you basically get a blank screen over there. Most IDEs have this, you probably know. So in my presentation, what I did was I had some code, and so it's on this GitHub page. Okay. And if you can't do this today, it's just follow along with me, and it's not a lot of code. So I just copied this code, just cut and paste, copy it here. So and this code is missing a word public. You get some errors, but if you just type a public.
No, we can't see it.
Yeah, I know, I'll expand it. Okay. Yeah. I do this all the time. Can you see it now?
Yeah.
Okay. All right. So let me just go through the explanation of this very simply. Okay. So the first line, the line number 1, is a pragma that says the Solidity version higher than 0.4. Okay. What this means is that this program will work for all versions higher. This is a mandatory line. Okay, and then what you're doing is you're creating a contract called Hello World contract, and all it is just saving a string for a word with a variable word, and then you created 2 functions, get and set. Okay, this is a trivial thing. So the get function, which is public, returns this word, hello world. And the set lets you just set a new word for this and return that new word if you do it. Okay, so this is just, the program is not a big deal. I'm sure you all understand this. What is a big deal is what do I do with it? So this is a Solidity code saved as .sol, and it is from this GitHub site, and I have this link, and the only thing I did was I added this word public, because it gives you a warning if you don't have it. Okay, then what you do is you compile it, and as you can see, one of the things you have to understand is the Solidity compiler has a lot of versions. Since your Pragma had something greater than 0.4, this will work, right? But you just have to look for a little bit. Is it greater or is it equal to? That makes a difference. So if everything is okay, it should compile. Okay, but there's a little bit of a difference here. So I'll explain what is happening. What is happening is it creates this contract, and this is like the smart contract. You can publish this on many things, like IPFS, and we're not going to get into some of these things. These are distributed databases that exist, but right now this is working on a simulator, so this is really not. So you compile this thing, and it created. Remember we were talking about ABI, the binary code. If any of you are kind of interested in drilling down, what is the compiled code? Just copy this in some text file and then check it out. Okay, right now I'm not going to check it out that much, but the ABI, the binary code is right there. Okay, so you compiled it. All right, big deal. Then here's the thing that you really need to do. You're running this on a virtual machine. You could run this for real in MetaMask and other things, but right now this is like a simulator mode. Just think of it that way. Okay, but there's a few other things that you want to understand. So this is a simulated account, and there's a gas limit. This is the limit. This is only so many gas that I can spend. But actually, you're spending no gas this time. Okay, so these are gas things that you can set. This is the contract that I just compiled. This is the code that this is the hello world contract. What you do is you deploy this to the blockchain, right? Again, this is a simulated environment, but this is just going through the steps. So compilation is the same thing, but deployment is a little different. So when you deploy something, you get some messages on the right, but again, I've expanded this so you can't see everything. When you deploy this, what happens is you get a deployed contract on a certain address, and that address, you can barely see this. You can barely see the hex code here. But it deployed the hello world contract at a certain address in the blockchain. Okay, that's what it did. Now you can copy this and all this stuff, but this is a deployed code in the blockchain. The code itself is trivial. Remember, we get word, you got that string. Set word, HITEC or whatever, anything, and set word. Then you get word, you get that. Okay, so this is just a simple code running, but it is running on this address. Okay, so this hello world contract is running. Hello world.sol has been deployed to this address. I mean, you can't see this too well, but it's right there, that address. And that's about it. Now, this is a simple code, it doesn't do much, but you can do a lot more with smart contracts and deploy them actually on the blockchain by just not deploying it in Remix, but using MetaMask. Okay, so this is about all I'm going to do in Remix today and the thing, but there's a lot more stuff obviously that you can do. Okay, so since we're kind of like closing in on our lunch, I made an account in OpenSea. So what is OpenSea? OpenSea is a marketplace for NFTs, all right? And it's fun for students, especially the creative students. If you're doing students who can draw or in fashion tech, I actually think there's a lot of potential here for people who are artists or creative folks to at least have an experiment with OpenSea. OpenSea is just a marketplace, just as Amazon is. You sell widgets on Amazon, you sell pictures on OpenSea. Okay. The first thing you need is a wallet. Okay. And why? Because you're deploying it to a blockchain, right? So MetaMask connects you to the blockchain. So let me just explain to you MetaMask in a little bit. So this is MetaMask right there in the window. And the most important two things you have to know in MetaMask that are critical. You go to the top middle left, it tells you which network you're in. You want to be in the main network. The second thing what you want to do is what is your wallet? Remember we were talking about wallets? That's your account. That's your public key right there. Okay. And then as I tell students, do not pay any money. So they all have zero. You should be concerned if they actually have Ether. But most of my students are like, don't buy anything. You don't have to buy anything in this class. Okay, so let's get back to OpenSea. So I have an account. And this is just like any social media. It's really not a big deal. All you have to do is create. Makes it that easy. And so what did I do? I took a picture of you guys.
Oh dear.
Well, because I had a picture of.
And we're gonna buy it.
Yeah, everybody's gonna buy this. So. Block. And I'll end up with telling you what this is and what this is not. Blockchain class, and then you can have an external link. Let's say you have your own website. Again, if you're to do this seriously, I'm a designer. I'm making jewelry. I probably have my own website. I have my own web, and so that's where you put in all this information, and then you put some description about what you're trying to sell. Okay, and of course this is all nonsense. We're just doing this for fun. And you have a collection. You can call it a collection. My latest jewelry, this, that, and there's a few attributes that you can put in. But but here's the main thing: the number of items that can be minted. But here's the main thing: you can put this on several blockchains. I've put it on Ethereum, but if you want to really go into Polygon, there's a few other things. Okay, there are clones. Think of them as clones of Ethereum. But for simplicity, let's just keep it on Ethereum. And all you do then is you create it. It just does the usual CAPTCHA. This is hard when people are all looking at you. I'll make sure I do it correctly. Right? Did I miss anything? Oops, I did. If I can't do a CAPTCHA, I can't do anything else. That's probably correct. Okay. And it just creates it. And this is instant gratification to most students. They feel good about themselves. They feel they're going to make a lot of money, blah, blah, blah. It's nothing. This is my collections. And so I just added all this. It's probably needs to be refreshed probably, but you'll see this in a bit. Probably a second. Okay, there you go. So these are my collections. So what actually happened? All right. So OpenSea accepts your picture as an NFT, but it's really not on the blockchain, and that's because I haven't paid any money. I haven't paid any gas. Okay. It's called lazy minting. They call it lazy minting. Lazy minting just means that it is all set to go to the blockchain. Okay, all set to go to the Ethereum blockchain. But this is really OpenSea's site telling you that yes, you have a bunch of collections. So they're making it easy for you to get in, an entry point, right? Look at all these pictures I've done. I'm not spent a cent. But if Anne wanted to buy this picture of this great Grand America Hotel that I have right there, look at, that's such a nice NFT right there. Then I would have to pay gas to put it up as a listing. Okay, so let's click on my image. I want to sell this, right? I want to sell this at a fixed price, whatever, 1 Ether or something. Again, I'm not going to buy anything. So this is setting up the price. So 1 Ether is quite a lot of money actually. Duration of 1 month. Then I pay the service fee right there. I don't know if you can see this. Okay, so it's nothing's free in this world. So the service fees come around when you try to list this officially, because if I don't list it, then nobody can buy it. So just think of whatever I've done as just a tentative catalog. Okay, that's the best I can say. So when I do complete listing, that's when it pops up and tells me you need to pay some money. And this is the price and all this kind of stuff. Okay, now I don't have anything in my wallet, so this I'm attempting to complete the listing. Okay, and for this you need money in your wallet, so on and so forth. So it's not that hard to do. It's just that students have to understand the process of listing and things like that. And how much does it cost to list? Again, I haven't done this for real. I can just say that it costs a few $100s at most, depending on the gas price. Okay, so you can probably spend $25, $30, $40. Again, these are just estimates, which is not zero. Who's gonna buy this picture of NFT? Nobody. So if I'm going to spend $20 to list it, it's just a waste. So you have to think of the economics of what you're doing here. All right. So
But hold on.
yes.
I totally lost something.
Yes.
You talked about it being like half a Bitcoin or something, or half a coin.
I can set this to whatever price I want.
No. The price for getting the smart contract on the system.
The gas fee.
It's just gas.
Yes, and the service fee of OpenSea, which is listed right there. The service fee.
2.5% of.
I'm looking at this. Listing is free. Once sold, the following fees.
Okay.
So I pay a little bit of gas to list. So let's just say $50. Okay, and I price this as $500. If you were to buy this, and it's all listed in their things. Their service fee is 2.5% of every transaction. So if I listed at $500, and you actually bought it for $500, they would take 2.5%. Now most of the people don't have fixed prices. What they do is auctions. So I can also use it as a timed auction, sell it to the highest bidder. So I have a you know how auctions are. I start off with a certain amount. And then I have a duration, So highest bidder. So most of NFTs are sold to the highest bidder. Okay, so you have fixed prices and auctions.
They charge the seller and the buyer.
They don't. They charge the buyer, the people who buy it. The seller pays gas fee for listing it. Otherwise, nobody would list it. That's a good question. Good point. So the service fee. Once it's sold, the service fee is deducted from what you get.
Okay. Got it.
And which is fair, right? It's in most marketplaces. I mean, most of them charge you. Like Amazon charges you money, and you get credit cards that also charges you money. Okay, so finally, what I want to do is I want to go to the wallet, which is a very important thing. This wallet is linked up to MetaMask is linked up to OpenSea. I can indeed add funds to my wallet so that I can pay for gas. How do you do it? It's very easy. Just put down your credit card and buy Ether with it. Okay, so $300, 0.2099 Ether for 304. So yes, I can buy it as easily like this, fill my wallet with some Ether, list my NFT for whatever gas price it is. Say my NFT costs $500. You buy it for $500, you pay 2.5% service, and I get the remainder back to me. I mean, OpenSea has made it as simple as that. I mean, how much more complicated can this be, right? Not that complicated. So what I'd like to do is end on this note. And you guys are dark. You got to go for lunch. Let me ask you if you have any questions, because I covered a lot of ground from the beginning of Bitcoin to today's OpenSea, and there's a lot more to cover, but I want to know what your questions are, how you want to use this content, what you want to do with it, so on and so forth.
Well, I would love to make $1 million, but hey, probably not going to happen.
Okay,
right away.
so let's go. I'll tell you what. Let's go back to where we started, which is blockchain.com. And tell me what the blockchain.com Explorer, and tell me what I love this site because it's so busy. What is the block number? 746651. Okay, Bitcoin. And so that's the block since we started this thing.
We started at 649.
Yeah, so 2 blocks have been created. 1 block took 41 minutes. Okay, so this is how I typically end the session, by knowing that blockchain was happening, and 1 block took a mighty long time. Okay, so if you wrote down the number that we started off with, 746,649, it's been really slow, really slow. Okay. The other thing is, click on the latest block and look for the number of transactions. I don't know if you can see it. There's a metadata that tells you, you see the fee reward. So now these things will make a lot more sense to you. Okay, it'll tell you the nonce. The nonce is the winning number. It'll tell you the transaction volume. It'll tell you the number of transactions. There were 2631 transactions in the latest block, the height of the block. So you'll understand a lot more things. Difficulty is actually the challenge, the challenge to solve the problem. There's a difficulty level. If there's a lot more miners, the difficulty goes up. Okay, so you'll understand this block a little more at the end of our class than you did before. And then just to play around, since this was an NFT, go to NFT and look for the top NFTs. I don't know, just end the session with some fun stuff. How much it costs. This is a 3,000. This person is asking 3,438, 2.5 ethers for this thing. Questions, comments, feedback?
Like how what is it, okay, this website organized, like let's say they put this on top, why it's on top?
Oh, that's just like a ticker. I mean, this website is, trending history. This is like Twitter. This is just giving you whatever's the latest. This is just one website's point of view. But you can drill down into something. You can see there are 3 owners.
I mean, you want to put yields on top. How you do it?
Yes, but this is the whole point, right? This is like the site controls this. You go to some other site, you'll have something else. This is blockchain.com's top NFTs. Okay. And so, you can have the class go through some of these things and just for fun. But it's important to kind of go through some of the steps to understand what this is before you jump into this page. So my question to all of you is, what are you going to do with all this now that you know? You're going to teach something? Or and how? How are you going to teach this in class?
I have a question.
Yes.
There's something called Pi. Have you heard of Pi?
What exactly do you mean?
MinePi.com. It's developed by some Stanford faculty.
Yes.
And they're actually mining on cell phones. MinePi.com. And I just thought it'd be interesting to put a course together with Pi, where the students could actually do some mining.
You can, but it's trivial. It's a trivial challenge.
Yeah, but there's some really good. They got a nice blog. They do a pretty nice job explaining and describing the technology.
Sure. No.
They don't let me teach this stuff on my campus.
Yeah.
You can't teach anything fun.
So, I have a course on this. I have 4 or 5 day workshops in this. I have like short sessions like this. You learn different things based on the length and duration. So, if you have any feedback or comments, let me know.